Welcome to less obvious substitution examples. So in this example, let's go ahead and evaluate the indefinite integral, integral of 4x times the square root of 2x plus 6 dx. So in this case, we do have a composition. Our outside function would be the square root. And our inside function is that 2x plus 6. So we can go ahead and take our inside function to be our u. So we'll set u to be 2x plus 6. So that means that du is derivative of 2x plus 6 is just 2, then times dx. And so we can go ahead and start with our, and then of course this means that dx is 1/2 du. So we can start with our substitution. We have the integral of 4x times the square root of 2x plus 6 dx is equal to the integral of 4x times the square root of u times 1/2 du. Unfortunately, we still have an x involved. So, but we know that u is equal to 2x plus 6. So that means that if we rearrange that and solve for x, we have that x is equal to u minus 6 divided by 2. And so we can go ahead and again substitute in. Our integral becomes the integral of 4 times u minus 6 divided by 2 times the square root of u times 1/2 du. That 1/2 and the u minus 6 divided by 2, those 2 divided by 2's cancel out our 4. We are just left with the integral of u minus 6 times the square root of u du. At this point, we can go ahead and play with our square roots and swap it out for a power. So here, square root u is the same thing as u to the 1/2. And so we can rewrite this as the integral of u minus 6 times u to the 1/2 du, or the integral of u to the 3/2 minus 6u to the 1/2 du. Both of those are fairly straightforward integrals using the power rule. We'd go u to the 3/2, we'll go up to u to the 5/2, then we would divide by 5/2, and we wind up with 2/5 u to the 5/2. Then we have minus u to the 1/2 will go to u to the 3/2. Divide by 3/2 is like multiplying by 2/3. So I'm actually going to give myself a little more room here. Let me update my screen. So again, we had our 2/5 u to the 5/2. Then we have minus 6 times, we would have had a u to the 3/2. And we should multiply by 2/3 since we're dividing by 3/2. So we have 2/5 u to the 5/2 minus 6 times 2/3 u to the 3/2, and then plus c, or 2/5 u to the 5/2 minus 4 u to the 3/2 plus c. At this point, we go ahead and plug back in the fact that u was equal to 2x plus 6. And we wind up getting that our integral is 2/5 times 2x plus 6 raised to the 5/2 minus 4 times 2x plus 6 raised to the 3/2 plus c. So in this example, the choice for u was fairly straightforward since we did have that composition, but it was a little more complicated. We didn't just have a f prime of u du situation. We had a little more further substitution to do. All right, let's do another example. Let's go ahead and evaluate the indefinite integral. 1 over all in the denominator x times natural log of x, and then dx. So in this case, it's maybe not quite so obvious what our u should be. So we can kind of experiment what our u should be. So this is a case where we will just experiment to find u. All right, so we've got we have x, 1 over x, natural log x, and 1 over natural log x are kind of our possible choices. And so if we look at these various options, we might notice that we have a function and its derivative combination. So note, natural log x and 1 over x are a function and its derivative combination. So as a result for this one, I would go ahead and pick natural log x, because then it's as our u, because then the du dx just naturally falls into the problem. So let's go ahead and set u to be natural log of x. Then we have du as 1 over x dx. If we go back to our original problem, we have the integral of 1 over x times natural log x, all in the denominator, dx. This is the same thing as the integral of 1 over natural log of x times 1 over x dx. Plugging in our u's and du's, this becomes the integral of 1 over u times du. That is an integral we know. This is natural log of the absolute value of u plus c. And then we can go ahead and plug in our known fact that u was itself equal to the natural log of x. So at this point, we wind up with the integral is the natural log of the absolute value of the natural log of x plus c. So again, we have the integral of 1 over x times natural log of x, all in the denominator. Dx is natural log of the absolute value of the natural log of x plus c. In the next videos, we will continue with some more possibilities for u substitution.